you are being asked to create a lab report using this GeoGebra tool. And I'm going to show you how to make a couple of these figures. So I'm going to start with a transformable triangle. I would like to turn that object off, and I'd like to turn that object off, and let's get rid of C. So this morning you wrote down everything you knew about transformations, how they were related to quadrilaterals, and how you could make figures simply by starting with a particular polygon, like this triangle here. And why don't we start with a rhombus, because there are some conditions on the rhombus's properties that we need to respect, and the tools here will let us use those properties. So I'm going to take the perpendicular line tool through point A, perpendicular to AB, so that I can create the kind of triangle that I would actually need to create a rhombus. I know that I need a four-sided figure that has sides of equal length. So I'm wondering what I'll get if I start with a triangle made with congruent segments that meet at a 90-degree angle. So I'm going to rotate the segment I just made, AH, 90 degrees around this point, and I'm going to go clockwise. So do you see how H prime is here? I can turn off some of these other figures. Simply by clicking on the show object. And I can even do that over here. Show object, turn it off. By right clicking, I can even find segment H over here and just unhighlight the box to turn it off. Segment DB, if I scroll over, it's going to tell me that that is segment I. Let's turn it off. I'd like K prime to stay on though, because it is the rotation. So I know it's a copy of AH. And now I'm guaranteed, because I've made this through a series of rigid transformations, to have a 45, 45, 90. So let's go ahead and measure this angle. I don't remember if GeoGebra wants me to go clockwise or counterclockwise, so counterclockwise seemed to work. And let's see how much movement we have here in this triangle. It looks like I can make it bigger by moving point A. It does not look like I can move any of the other points, so A is the point that I can move. Now I've got to decide exactly what to do with it to ensure a congruent figure. I'm going to make it into a polygon so that I can transform the triangle itself rather than each of the pieces separately. And one of the things I can do is reflect it, this whole polygon, over this line segment. Now I know that that's a rhombus, but that's kind of a particular rhombus. That's a square. So I'm not sure that I want this rhombus to be a square. So I'm going to rethink that transformation. What if, though, I reflected the figure over the short side, or one of the legs? And what if I did that again? And what if I did that again? I kind of like, this is still a square. I kind of like, though, that this shows that the properties of the diagonals of a square are that they bisect each other and that they are perpendicular. And we can show that by a series of transformations. If each leg is simply copied once, twice, 3 times, I know that this midpoint is a bisector of this segment from H prime to H double prime because it was made by copying a triangle leg over and over. So that was a good figure for creating squares, even for creating diagonals. If I really wanted to illustrate the diagonals as one piece, I could add the segments separately, and I could turn off some of these labels so that the picture wasn't quite as busy as the one I'm getting. I can turn off the figures. Sorry. I want that object just to go away. I don't really need this midpoint anymore. I don't need D. I don't need the label for H prime. So let's find H prime. I'm going to right click on it over here and I'm going to turn off the label. For some reason it's not turning off the label for H prime. I'm not sure why. So I'm going to have to live with that. But segment H prime, I don't need that label, it's kind of in the way. K, I don't need that label. What happens if I turn off polygon 1 and 2? K comes back. That's kind of interesting. I can go to object properties and I can turn off this 90-degree label. So there's things I can do to kind of clean up this image. So how about if I make an isosceles triangle, but it isn't a 45, 45, 90? How can I do that? Well, I could create a segment here, and I could rotate that segment, but I'm going to be careful not to rotate it 90 degrees this time. So my transformation for rotation around a point is here. I would like to rotate this segment around point L, something that's not 90. How about 65? And if I connect these points, oh, you know what? 65 is not a great rotation because it looks a little too much like an equilateral. So I'm going to revise that. Rotate around a point. Let's get something, I don't know, 30s are interesting. So let's rotate this figure around L. Didn't mean to do that. 30 degrees. And then I have a copy of the segment, so I'm certain that I have an isosceles triangle. Will that help me to create quadrilaterals that are interesting? Well, let's find out. How about if I rotate this triangle around this point 3 times in a way that will finish this figure? Well, I know this was 30, so these two angles together must be 150. Half of 150 is 75. Rotate it through this point, 75, in a clockwise direction, 75 degrees that is. That didn't work. So I'm illustrating here how the goal really is for you to play around with these tools, see what happens when you do certain things. How are you going to get certain figures? So keep experimenting. Rotation of 75 didn't work. What happens if I reflect this figure across this segment I've just created? If I keep doing that, I will get an interesting figure, but it's going to have many, many sides. It's going to be a quadrilateral. It's not going to be a quadrilateral anymore. So though it's interesting, I might play with it a little while, but it's not going to be in my finished product because it's not going to make what I'm planning to make. So you need to think your way through this problem. How can I use a set of congruent triangles to create what I'm looking for? I'll show you where the midpoint tool is. Midpoint of this segment. And remember that one of the transformations we played around with was to rotate a triangle around a midpoint 180 degrees. What kind of figure does that give me? Counterclockwise, clockwise, doesn't matter. And am I able to build the rhombus that I'm looking for? Well, not yet. So what would I have to have in order to get a figure? Which one of these will allow me to move it? What would I have to have in order to get a figure that is a rhombus? What if I reflect the figure over the one non-congruent side? Does that give me does that use a transformation that guarantees that all four sides are congruent for this rhombus? I've copied this side to make this segment or side, and now I've copied the whole figure to make this figure. So let's make a quadrilateral out of this new figure. And the properties of the rhombus given on that page are a quadrilateral with four sides and equal lengths. There are some additional properties of quadrilaterals that we can find on Cool Math. One is that a rhombus will have diagonals that bisect each other and that are perpendicular. So knowing that, what kind of triangle would I have to have created? I need a regular point tool so that I can show you this figure here. I want to measure this angle. I want to show you that it's this 90. So if I had created a triangle, let's get a line segment. Let's get a line perpendicular to that segment through this point, and let's add another point to it. And let's create a polygon that we now know has a 90-degree angle because it was created on points at a 90-degree intersection. We can turn off this line. What happens now if I take this 90-degree triangle and I continue to reflect it? What if I reflect this now over this line and this now over this line? Have I created a rhombus in a different way that still contains equilateral triangles? I have. Because these are copies, these segments are copies of each other, I can take the rhombus that I created with 4 triangle transformations and I can take it apart into isosceles triangles if I want to. The text box tool is here. This tool allows you to type in the definitions, and I'd like you to use it to do that. And I want you to test your figures. If we go on our gallery walk tomorrow and we try to move your figure around, will it remain a rhombus no matter what? This one is guaranteed to remain a rhombus because we've created it out of a figure that contains the conditions necessary for perpendicular diagonals and for congruent sides. So good luck. I'll see you tomorrow.